Yo, what's up, my chat? What's up, chat? So today, I'll be trying to solve the India's most reputed professor named H.C. Verma. Verma is a professor from India and well-reputed professor for his book called Concepts of Physics, and I got it from India. Uh, yeah. So yeah, we'll be trying to solve it and complete as much as possible today because uh, I have some assignment to complete it, so we can try to complete it in I have 5 days period of time, and I need to complete the 11th part of this H.C. Verma. And yeah, I heard it's a very good book from India, and yeah, not only India, and it's also being used in the worldwide, like from other professors as well, because it's a well reputed book. Yeah, it has a lots of a problem. So we'll be starting right now, and simultaneously I'll be making notes, like note of the answers which I got in a paper and a pencil. Okay, let's begin exercises, and yeah, we'll be doing all chapters exercises, and the chapters which we are gonna cover today is like this is gonna be around 10 hours or 11 hours, 9 hours, 8 hours stream, like that. Okay, NLM, we'll be covering NLM, and we'll be covering friction, we'll be covering friction, we will be covering circular motion, circular motion. For these two, we need to do theory. I'll be doing theory revision of the H.C. Verma. I have the theory itself is also good, and work and energy optional, work and energy. Then we'll do COM, then RBD, then fluid mechanics, fluid mechanics, fluid mechanics. This will be the order. This will be the order of a completion of the chapters, and mechanical properties, properties of the matter, properties of the matter. Yeah, let's begin. We don't have that much time, so let's lock in. Okay, alright. Exercise, exercise. I mean, if I know the answer, okay, we will be starting from exercise. I have completed the first two questions, so we'll be going with exercises. NLM, 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 and yeah, from third question. Okay. In a TV picture, okay, you guys can refer and solve simultaneously. It's page number 79, page number 79, page number 79, and this is the third question. In a TV picture tube, electrons are ejected from the cathode, okay, with a negligible speed and reach a velocity. Okay, that means negligible velocity speed means it was from the rest, and reach a velocity in traveling 1 centimeter. Okay, s is equal to the distance is equal to 1 centimeter. Assuming the straight line, find the constant force exerted by the electron. Okay, you have to find acceleration and multiply with the mass. Okay, nothing else, nothing else. 1 into 10 to the power minus 2 is equal to since was released by half at square. Okay, wait. Uh, into 2 into a, and using equation of motion, and 5 into 25 into 10 to the power 12, 10 to the power 12. Okay, this will be the acceleration. 10 to the power 14, 25 by 2, acceleration 25 by 2 into 10 to the power 14 into 9.1, 9.1 into 10 to the power minus 31, and I guess cancelled. I mean, this will be 12.5 into 9.1 into 10 to the power. I guess it's uh, around 10 to the power. This will become 13, and 13 means 23, 17, 10 to the power minus 17. Alright. Yeah, 10 to the power minus 17, and what is 12.5? 12.5 into 9.1. Do we need to use calculator? No. I need to complete this very quick, and I don't have a calculator. Into 9, let's consider it to be 9, 5, and 18, 18 plus 4, 9 ones are 9, 112.5 into 10 to the power minus 17. Yeah. And I guess that's the third question completed right now. Let me check the answer, verify the answer. I hope it's correct. Yo, wait. Yeah, yeah, they are correct. And if we take two decimals inside, it's gonna become like 1.125 into 10 to the power minus 15. That's what I got it. So that's the third question being completed right now. And actually, I want to solve hard questions. So, okay, let's try some pulley based questions. 2050. Like, I will return back. Wait 1 second. Uh, 1 second. I need to copy this shit. Okay. Then move on to the 25th question. I mean, this is a pulley based question. Okay. So, consider the situation: all the surfaces are frictionless, and the string and the pulley are lightweight. And this is 1.0 kg, and this is 1.0 kg, and this is 3 meter, and this is 4 meter, and this is 5 meter. All the surfaces are frictionless, and the string and the pulley. Okay, find the magnitude of the acceleration of the two blocks. Okay, what will be this angle? This is gonna slide, this is gonna slide, and this as well, this is gonna slide, but they both are constrained to move with the same acceleration, and we need to find the magnitude of the acceleration of these two blocks. Yeah. If I draw the perpendicular from here all the way, and this is 1 kg, but how do I find angle though? Okay, this is tension D, tension D, this is 90 theta. I don't even know the angle. How can you find the angle here? I forgot to start the thing. So, okay, this is 3 meter, this is 4 meter, this is 5 meter, all right, all right. Now, what can I do from here? Consider the situation shown in the figure. Uh, I mean, we need to be quick though. I mean, these are JEE mains level of questions. Uh, okay. But how do I find angles though? I mean, we need to take the component. So yeah. Okay. And I think okay, I got an idea. Let me consider this will be 5 minus 6 and yeah, better I guess. Yeah, better. The only option. Okay. Okay. And yeah, the common set. Okay. 9 minus x square. Alright. And for the another part, it's gonna be perpendicular whole square is equal to 16 minus 25 plus x square minus 10x. Alright, these two has to be equal. 9 minus x square is equal to 16. 16 minus 25 is 9. Plus x square minus 10x minus 9 and 2x square plus 18 minus 10x, and I guess it comes out to be x square minus 5 and plus 5 actually. No, minus 5 minus 5x and plus 18 plus 9. Okay, I need 9. So this is 9, 3, 3. Okay, 3. Shit. What else did we do? Mistake. 16 minus 25 minus 25, and this is also supposed to be minus plus. Okay, minus plus and x square gets cancelled. Oh my god. This, no, no, not this. 18 is equal to 10x 1.8 meter. X is equal to, if x is equal to 1 meter, and I think the perpendicular will be 18 by 10 ka whole square and 100. What is second? 18 Okay, that's the perpendicular. Okay, now we can find sine theta 1. This will be theta 2. Theta 1 would be equal to, what is the perpendicular? 324 by 100 divided by what is the hypotenuse? 324 by 3 into 100, and this is 108 108 1.08 into g sine m into mass 1 kg minus tension is equal to mass into acceleration, and your tension minus, and for that sine theta 2 would be equal to 1.8 320. Oh wait, what? No, we are supposed to subtract, right? 900 minus 324 by 100. will be around 9, 9, 7. This will be 8, 8, 5, 576 by 100, 576 by 100. I mean, so that's perpendicular is equal to 5.76, 5.76, 5.76. Now 5.76 divided by 3, divided by 3 into g 10 into 1 minus tension is equal to mass into acceleration, and in another case 5.6 divided by 4 into 10 uh, is equal to mass into acceleration. In the both cases, I guess this is 4 ones are 4, 1.44, and here ones are 0.92, 1.92. Okay, 14.4 tension and is equal to acceleration, and here it's like 19.2 minus is equal to acceleration. If I and 19.2 minus 14.4 is equal to acceleration, and this is point 0.8, and here it will become 8 and 8, and this is going to become 4.8. I guess the acceleration is so. Oh, I hope so. I think I hammered on and a lot of mistakes should be so. Yo, what? The answer is G by 10. What the fuck? I mean, yeah, it's completely wrong. Completely wrong. I mean, okay, I'll just check into the solution. I mean, how the fuck did I get it wrong? I mean, like, I considered the perpendicular and shown in figure. I mean, I might have done in calculation mistake. Wait, let me check. We took p square minus, okay, and in another case it will be 16 minus 25 minus x square plus 10x, that is okay, and it will become minus 9, and if I take it will become 18, and x square gets cancelled, and x square gets cancelled, and yeah, 10x is equal to 18, and it just comes here and it becomes 18. I mean, okay, okay, 5 e9, 5 e9. 5 e9. What? Yo, bro, I don't understand how did I take it. Sin theta 2 is 3 by 5. Yo, how? I just asked actually, bro. What the fuck is this explanation for? I mean, like what? Oh, yeah, it's a right angle triangle, right? I mean, the figure. Oh, 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 shit, we are dumbass. I mean, I am dumbass actually. Yo, this is a right angle triangle. I mean, the figure. Oh, shit. This is a right angle triangle. This is 90 degree. That's why. I mean, it's like inverted. Or yeah, nothing else. Yeah, you have to do the same, but instead, I consider sin theta one. I mean, yeah, good shit idea. Yeah, nothing else in discussion. I mean, like, where to solve this shit. I'll solve it again in my notebook because yeah, I missed already. Theta one. I thought it was not right angle triangle, but I was so dumb. I didn't check because it was 3, 4, 5. I mean, it's to satisfy the Pythagoras theorem. My bad, guys. 4 by 5 sin theta to 3 by 5 theta 1, okay. 1 into 4 by 5 minus tension is equal to mass into acceleration 3 by 5 by 3 by 5 minus is equal to mass into acceleration if I cancel, and if I add 1 by 5 is equal to mass into acceleration 2 ma means like g 4g 3g, okay, g by 5, and it comes out to be g by 10 is equal to acceleration. Alright, yeah, nothing else. Now next we will move on to the okay, that was 25th question. We will move on to the 26th question. Yeah, we'll try to speed run as much as possible. Like, you're a little bit slow. 26th. M2G 26th one, okay, M2G, and this is the constraint motion, and this is M2, okay, so M1 into acceleration, okay, wait, okay, and here, like, like this, bro, M1 tension, and here M2G by 2. So M1A is equal to tension minus M2G by 2, M2G by 2, and M2G by 2, M2G by 2 minus M1, minus tension is equal to M1A, and due to which this will move upward, I hope so. Tension minus M2G is equal to M2A. Now, if I subtract the tension and the M2G, I think minus M2G, that means it's gonna move in the forward, and M1 plus M2 A is equal to, okay, and minus M2G divided by 2 M1 plus M2, that will be the acceleration minus, because it's gonna move in the opposite direction which we assumed. So yeah, that's all. We'll get the answer as acceleration is equal to minus M2G to M1 plus M2. Okay, this will be the acceleration. Like, this force is equal to M2G by 2. They are given in the question. Okay, we solve it. Yeah, there's nothing else. They are doing a task for tension. Thank God. I don't have that much time. Yeah, towards the right. That's what. You assumed it to move in the left side. That's why I got 8 negative. Okay, 27th. Okay, there is a pulley base like this. Like this. Okay, and 27th. I'm solving in 2 books simultaneously. One is for like another one is like I'm copying it in a notes, which I need to show to someone. M1, M2, F. Okay. Force F, M1, M2, force F. Okay. Alright. Describe the motion of M1. Okay, we need to basically find the acceleration, and M1 is equal to 5 kg and M2 is equal to 2 kg. Force F is equal to 1 Newton. And I mean, there was a formula, right? I forgot it. I did it. I used to use it while solving like forces cost. I mean, acceleration due to unbalanced force. Due to unbalanced force. Method of solving for acceleration. In the pulley based questions, yeah, I mean, like you have to consider the unbalanced force. That was a simple way. F net, a 10 kg M1G plus F, M1G plus F, and plus M2G. Then we need to add. Wait, let me check the equation. Plus F minus tension is equal to M1A and M2G plus F minus tension is equal to M2A, and I guess this is cancelled. Yeah, this also is cancelled if I add up M1G minus M2G is equal to M1 plus M2 acceleration, and yeah, that will be 7A is equal to, because they are given the, and this will be 50 Newton minus 20 Newton, that is approximately 13, I'm not approximately, it's okay, 30 Newton by 7, 30 by 7 is the acceleration, and 30 by 7 is the acceleration. Describe the motion if the string, okay, now we have a sub question for this. First, let me check if the answer is correct. 27. What is 4? That's approximately 4.3. Yeah, this number 4.3, and it is moving downward. Okay. Now wait, let me copy this. Let me copy this real quick. Unbalanced force. Acceleration A bar is equal to M1 plus M2, M2G minus M1G, and that is approximately 7. Why the fuck am I saying approximately? Okay, A bar, I mean this approximate, oh fuck, yeah, approximately 4.3 meter per second square. Okay, that was 27 question. Now we have a sub question in this. The sub question states that what if I break the string? If the string breaks, but F continues to act. Okay. Describe the motion of M1. Okay, where M1 here the string is gonna cut. If I'm gonna cut the string, the tension is gonna stop acting, and M1 is gonna move. M1 is gonna move. M1 is gonna move in a downward direction. Is gonna move in a downward direction with an acceleration of, here M1G and F is acting, and we can find the acceleration. Acceleration is equal to M1G plus F, and 1 Newton. Uh, uh, what was the mass of the M1? 5 kg. 50 plus 1. 50 plus 1 divided by 5. I mean, it's like 51 by 5, and it's gonna move with 10 point, 10.2. Yeah, 27th. G with yeah, it's exactly correct. Okay, that was 27th. If the string was cut, this M1, this is M1, and this is M1G F, and if I consider F body, I mean what the fuck, I mean F free body diagram, M1G plus F is equal to, okay, and acceleration is equal to M1 by M1G and F by M1, and that is 0.2 meter per second square plus G. That is the acceleration, and this is the answer. Okay, alright. So that was alright. Now we move on to the 28th one. Okay, 28th. Okay. Okay, this is the Now this is the question, and it is a double pulley based question. Okay, this is M1. Okay, this is M1. This is another pulley. This is the another pulley. It is of M2, and this is M3. Okay, okay. Fine. We need to find the acceleration. Acceleration of M1, M2, acceleration. The string is 20 centimeter. The string from the upper pulley. Okay. Okay, first basically I need to find the acceleration of M1, M2, M3. Okay. Now these two are gonna move with the same acceleration. Okay, and I can find the acceleration of this pulley. What will be the acceleration here? It will be M3G minus M2G divided by M3 plus M2. Acceleration will be equal to, acceleration will be equal to around 30 Newton minus 20 Newton, 10 Newton by 5 Newton. That's, 5, okay, 2 meter per second square, 2 meter per second square. This is tension. Here it's gonna become P by 2, right? Okay, I got an idea of 15 Newton minus acceleration. 10 Newton minus 10 Newton divided by 16, 60 by 3s are 20s are 20 by 3s are 20. I don't think I'm correct. Let's just calculate. Oh shit. Not even close. Oh, alright. We're gonna move with different accelerations. Oh, wait. This is double pulley system, right? Okay. Mm, we have to imagine the situation. If this is gonna move by the distance x, this is gonna move distance downward by the distance x. Right? Yeah, sure. Like the 2 meter per second which we got was with respect to this, and since this is also moving, it's gonna gain some extra acceleration. Okay. A1 into is to D A3 A3 I mean wait A1 is equal to A1 is equal to A1 yeah. Now I need to find the tension T M1G minus tension T is equal to M1A A1 and M2G minus T, okay, 2M2G is equal to 2M2A and M3 M3G minus T by, I mean, what the fuck am I doing? T by 2 minus M2G, I mean, 2M2G, this is M1, alright, is equal to 2M1 M2A 2M1G minus 2M2G is equal to 2M1 plus M2A M1G minus M2G is equal to M1 plus M2. Yo, wait, what the fuck? Okay, I'll just subtract. Yo, what the fuck am I doing? I'm getting confused. Okay, I'll subtract minus 2T and 2M1G plus M2G is equal to 2M1 plus M2. Wait, no, fuck this shit, bro. I'm doing some shit wrong. I mean, like, I'm not able to understand my own everything. I'm just gonna search. I don't have time. 1 is equal to 1 kg. M2 is equal to. I mean, like, I did so many mistakes in like oh, wait, what? Yo, guys, what the fuck? Yo, wait, you guys weren't able to see this whole stream. Wait, what the fuck? Oh shit. Wait, this whole stream, you guys couldn't see the. I mean, the same thing. Change to the 28. Yeah, you guys understood. Like what I did was like, okay, they consider this will move with some acceleration a1, and due to which, okay, this is gonna move with some acceleration. It's gonna have an it's gonna add a pseudo force, and that acceleration will be different. That's what it is. Okay. And one second. Oh, I heard Resident Evil Requiem is literally blasting the internet. Oh shit, the title itself is by mistake. I wrote speedrunning Rafa. I need to change that. Shit. Let me pause the timer. Let me pause. I mean, I'm not even able to hear my own voice now. This is so low pitch. Uh, yo, guys. This whole time you guys couldn't see the stream. Yo, how did it even get got swapped? Shit. My bad, guys. I hope it's perfect. Yo, guys. This whole time you guys couldn't see the stream. Yo, how did it even get? Shit. Let me just change the shit. Okay. Yeah, we can start. Alright, the 28th question. So yeah, the 28th question. I got I'm just gonna copy it again. I'm just gonna solve it again in my notebook. Wait. Yo, I actually am surprised that this whole stream I wasn't streaming this whiteboard. Instead, I was streaming a Google. Yo, that's actually crazy. That's actually crazy. I know, man. That's actually crazy. Okay. So I need to consider the constraint. A1 is equal to A net. Okay, 28th question. I mean, it was a kind of good question, like pseudo check. I mean, GR, good question. Now, we'll move on to the 29th question, and okay, 29th. In the previous problem, suppose M2 is equal to 2.0 kg, M1 M3 is equal to 3.0 kg. I mean, this is also variable though. Never mind. 29th is okay. We'll do 29th actually. We couldn't do. M1 is moving with an acceleration A1. M2, M3. If this is moving down with an acceleration A1, 1 kg. M2 is equal to 2 kg. M3 is equal to 3 kg. Oh, I'll be right back. One second, I'll be right back. What's up, chat? I'm back. Okay. Okay. So, okay. We know the mass of M1. We need to specify the mass of M1 so that the system remains at the rest. We need this to remain at the rest. So, M1G is equal to tension, right? If that is the case, we need a tension. We need to find a tension. That's nothing else. I mean, we found it earlier. M2G tension is equal to M2A, and as we found it 2 meter per second square, and 4 plus 24 tension and 2.4 kg, 29, 4.8. Oh, come, bro. Oh, okay. This is T by 2. So it's gonna be 48. Tension T is equal to 48. And if I substitute, we'll get 4.8 kg. Okay, alright, that's all. Now we move on to the 30th question. Come on, we need to speed run. 30th question. Now we'll move on to the 30th question. Calculate the tension. One kg. Tension in the swing shown in the figure. Okay. Tension T. Tension is equal to acceleration, since it's 1 kg, and here 10 minus T is equal to acceleration. 2A is equal to tension, and 5 meters. Acceleration is equal to 5 meters per second square. And you can find the tension. Anything else? Let me load this on. 30th. Tension T is equal to acceleration. T 10 5 Newton. $31. 2M. 2m here 2d is gonna act 2t 2t is equal to 2ma tension is equal to ma and your tension m1g minus tension is equal to okay capital mg minus tension is equal to ma and 2ma is equal to mg and gets cancelled. G by 2 is equal to acceleration. G by 2 is equal to acceleration. Okay, alright, you'll get acceleration as G by 2. No, I need to solve. I mean, you can just get it easily. Telling you, it's special for that. Yo, what? 2G by 3. Now, so states that it's 2G by 3. Right. How is it 2G by 3? Okay, let me check the solution for this shit. Oh, man. It's also gonna move with different acceleration, right? Due to different tension. What do you forget? Due to constraint motion. Okay. Okay. Alright. Understood. Like, we cover the constraint motion, they are not moving with the same acceleration. 2m mass will move with the acceleration a by 2. 2m a by 2 is equal to 2m a by 2 is equal to tension 2t. MA is equal to 2t. Now for the MA, we have mg minus MA by 2, and yeah, 3MA by 2, m gets cancelled, and it will come out to be 2G by 3. 2G by 3 is equal to acceleration. 2G by 3 is equal to the acceleration. Okay, and yeah, we can find the force exerted by the clamp on the pulley. Okay, it will be the resultant of the two tensions. Okay. Let's move on to the next question. 32. I mean the force which should be acting. Yeah, you guys understood right now. It's gonna be A by 2. This is gonna move in this direction with an A by 2. This is gonna move with an acceleration A. Alright, m1g minus tension is equal to m1a, and this tension comes out to be ma by 2, and 3ma by 2 is equal to mg gets cancelled the 2g by 3 acceleration, and I need to find the tension next. After finding the tension, this will be the resultant, and the resultant is that will be cos theta is equal to 90 degrees. This angle between the two vectors, so it's going to be d square plus d square under root of t by root 2. Right, that's all. I need to find the tension. Tension will be equal to 3mg by 4. 3mg by 4. mg by 3 root 2 mg by 3, or resultant. Now 32. We have around 10 more questions to complete this NLM. I need to go to a washroom. Will be right back. So, alright, now 32, right? Okay, 32. Okay, this seems to be a good question. Here, 30 degree, and my find the acceleration of the block of a mass m in the situation shown in the figure. All the surfaces are frictionless and the pulleys and the string are light. So this is going to move with an acceleration of mg sin theta, mg body sin 30 degree 1 by 2, 1 by 2. And okay, first of all, the mistake not to make is that these two are going to move with different accelerations. This is going to move with an acceleration a by 2, and this is going to move with an acceleration e. Okay, so best way to solve is this mg sin theta, I mean unbalanced force. Oh, right, we cannot use that. Okay, to the 2m ma 2mg minus 2d, and here tension minus mg sin theta is equal to mass into acceleration, and 2 common 1 minus sin theta 1 minus sin theta is equal to 2ma, and what is 1 minus sin theta? 1 by 2, 1 by 2 g by 2 acceleration, and acceleration of 2ma will be acceleration of 2ma will be g by 4. Yo fuck, mistake again. I think it was a constraint duration because I put the cup. I put the cup. This is going Oh, wait. How can we be so dumb, guys? How can we be so dumb? It's actually 3. Okay. Yo, it's 3. Oh, shit. Yeah, anyway, I knew it, man. But I'm like, I'm from West Indies, so I mean Africa, so I have the rights to say N word. Okay. 2 mg, is cancelled, and this is 3 8, 1 by 2, g by 3 acceleration. Yeah. 35. Find the acceleration. This is 35. Okay, we forgot 30. No, this is 34. We forgot 33. I will do 33 of this. Yo, it's 10 minutes off, but I'm gonna make it one more session because it's just wasted a little bit of time in the middle. So yeah, I'm gonna compensate that time, and yeah, so 5 kg, 4 kg. Find the acceleration of the blocks A and B. This is block A, this is block B. In the three situations given below. Alright, this is 2T, this is tension T. This is gonna move with an acceleration A. This is gonna move downward or upward, A by So if I consider the FBD, tension minus 40 is equal to 4A. Here 50 minus tension is equal to 5A by 2D. So 2D minus 80, 8A, and minus 30, and add 16 plus 5, 21A by 2 is negative 3 7s are 3, 20s are minus 20 by 8, 20 by 7. We assume that tension minus assume that is, but it actually moves downward, and what else? Yeah, absolutely. Yeah, we were correct. I'm copying the right method. I'm copying the thing. As I told, I had some homework and this is part of the homework. Okay, we move on to the question B part of this question. I mean, we are solving the important questions of this part of the question. I mean, rest of the 20 questions are easy, and some questions, yeah, I need to refer back. First, we'll complete the. Okay, this is the system. I'm solving the same question to 10. That's crazy. kg. Okay, here it's fixed. Alright. If this moves with an acceleration a, this is 2t, this will move at an acceleration a by 2. So 5 50 minus 2t is equal to 5a by 2. And what about this? It's going to move with an acceleration tension is equal to 2a, 2d, 4a, 4a, 2d, and just add it 50. 50 is equal to 8a, 8a, 8a plus this is approximately 18, and so it becomes 13a by 2, and 5g, 10g, 10g by 30 is equal to acceleration. 4. Okay, yeah, we were correct. Okay, we need to find okay, we can just find the block, acceleration of the block B simultaneously, and it's gonna be divided by 2, it will become 5g by 13. Yeah, nothing else. And 550 minus 2t is equal to 5a by 2. Tension is equal to 2a and 2t is equal to 4a, and 50 is equal to 13a. When I add up two equations, and it's going to become 30g by 13 is equal to acceleration of the block A, and acceleration of the block B will become 5g by 13. Alright. 1 kg, 2 kg, acceleration of A, acceleration of and okay, this is kind of tricky. This is tension, this is going to be 2D tension, yeah, this is also going to be the tension, so this will be like it might move A by 2, this will move acceleration A, tension minus 20 Newton, 2G minus 2G is equal to 2A, and G minus 2T is equal to A by 2, and you multiply minus 4G 4A, and here G minus 2T A by 2, and add it's going to become minus 3G, and this is going to become 8, 9A by 2, 9A by 2, minus G by 9, acceleration minus 2G, okay, minus 2G by 3. It's minus because it means that it's actually going to move downward at an acceleration A, and that acceleration is 2G by 3, and acceleration of block B will be equal to G by 3. Okay, so we completed 34, so we're going to move it for the 33 question. 33rd, which we were supposed to solve earlier. This is block of a mass M kept at angle theta. 33. Okay, it seems to be a good question. Find M dash such that M does not slip. the m dash, not the slip. I mean, not m dash. Let's have the small m. We need to ensure that the small m does not slip. So to ensure that small m does not slip, okay, this angle is theta. This angle is theta. This angle is theta. Alright. That is mg. Okay, if this moves with an acceleration a, this block of mass m dash moves with an acceleration a, and okay, this will also be theta, and this should be a cos theta, and that pseudo force ma cos theta should be equal to ma cos theta should be equal to mg sin theta. So acceleration is equal to g tan theta. Acceleration should be equal to g tan theta. Okay. Acceleration should be equal to g tan theta. Alright, now if acceleration is g tan theta, then on the block of a mass m we have tension acting, due to which it's gonna move tension mass into acceleration tension, and this is gonna fall downward with an acceleration a. Mg minus tension is equal to ma m dash, okay, and mg m dash plus ma, okay. Now that should be g tan theta. That should be g tan theta. So I can take tan theta common here. M dash plus m is equal to m. Now m minus m tan theta divided by tan theta is equal to m dash. So this should be the mass. And 1 minus tan theta. This is tan theta. Okay, yeah. Nothing else. Okay, we need to find the mass m dash. No, wait. We did a mistake. With an acceleration m plus m dash plus m. We need to find m. Okay. Acceleration is equal to tension, and mg minus tension is equal to mass into acceleration, and mg common 1 minus tan theta is equal to minus t is equal to tan theta mg minus 1, and here we also have m plus m dash g tan theta. I mean g gets cancelled, and here we have tan theta minus 1 and if I need to write it in terms of a 1 by cot theta minus 1 m dash plus m, 1 by cot theta, and if I take m dash plus m cot theta, and here we have 1 minus cot theta divided by cot theta, and yeah, 1 minus cot theta. I guess this is the answer. Okay, this is the answer. Yeah, that's all. That's gonna be the mass of a M1. Yeah, nothing else. Okay, so that is a very good question. Very, very good question, I would say. So far, this is a good question. I just balance the force MA cos theta should be equal to mg sin theta. That zero force should be balanced so that it will not slip g sin theta. And I consider this was a whole system, that is m plus m, and m plus m, m dash plus m is equal to g. Acceleration should be equal to tension. Now from there, then we know that mg minus tension is equal to m1a and a, and I just transfer this here. A minus g is equal to minus tension, g minus a, tension, m plus m, g tan theta, here mg, and 1 minus tan theta, 1 minus tan theta. I just wrote it in terms of a cos theta, and we got it as cos theta minus. Right away, it's cos theta minus 1. I forgot the negative sign. It's 1 minus tan theta, actually. 1 minus tan theta. Yeah, alright. 33, now B is also done, C is also done. Now we are going to the 35. Let me just zoom it off. I actually love this question. Okay, I mean, it was a very good question. Right. How many questions did we solve so far? We have solved 35. We have solved exactly 10 questions. I can't believe, actually, very low. Oh, we had some questions also, right? I mean, it's okay, not bad. And grams, 50 grams, 30 degree, 500 grams. Okay, I need to find the acceleration of the 500 grams. Okay, now this has an Okay, tension 50 into G, 50 G minus tension is equal to 50A, and there G 50G minus tension 50A. I mean both the same expression. This is useless expression. Now 500 G 500A 450 G minus 450 G 550A 9 11 minus 9 by 11 minus 9 by 11. That means it's gonna move. Actually, it's gonna move downward. It's actually wrong. So I mean, are they gonna move with different acceleration? $500 grams. I'll just check the answer now. Find the acceleration of the 500-gram block in figure 3E E18. Not this one. Oh. You have an extra tension to take into the consideration. Yeah, I forgot one force here. I forgot one force here, that is tension T1 and here T1. I forgot one force T1 and here T1. Forgot one force. That is T dash. Okay, I'll consider it T dash better. T dash. And should be equal to 0.18. Oh, what is T1? T1, I mean, yeah, 0. 0.095 G plus tension is equal to 0.015. Now, yo, it's lagging. I need to change the setup. Be right back. No, I won't go. I mean, I'll change this of the solving discussion. And yeah, 0. I guess if I add 0.5 here, it's gonna become 1.45 G, and here it's gonna become 0.65. Okay, 145 G, 65 A. 5 twos are 29, 5 ones are 13. I don't think this is correct. Yeah, there is a mistake. I mean, it might be addition though. I guess we're supposed to subtract it. This is minus and this is minus T. Yeah, now it's perfect. Okay. 0.045. So 45 G by 65 acceleration, and it's 8 G by 13 acceleration. Okay. So yeah, we forgot to include. Okay, so whenever we have these kind of problems where there is a block which is connected by one string here in this direction, and there is another string which is connected in this direction, where you consider this has a different tension and this has a different tension, and you consider this as some tension T dash, and that T dash can be found by the another relation where this T dash will be connected with another block. So yeah, this was also a good question though. So yeah. I mean, we have solved a lot. So yeah, we'll be starting new page. Oh, that is shit, a lot. Yeah. We completed 35, which again was a good question. T1 minus, I need to copy it, 50G is equal to 50A, and for 50 G plus T. T1 minus I in pocket 50 and okay, T dash is equal to plus T 50. Okay. 0.1. Yeah. Alright. Now we'll move on to the 36th question. Okay. So a monkey of a mass. Okay, there is a monkey. 36. Actually, I'm exhausted. I did 1.5 hours. Little bit fresh up break. Alright. Let's begin. Yeah, again. 36. Okay. There is a monkey. Okay. A monkey of a mass. This is the rope. It's going upward with an acceleration e 1 meter per second square. Monkey mass is equal to mg, 15 kg, 5 meter long. How much force should it apply in order to move up with an acceleration e? That force applied, F applied minus mg is equal to, since it's moving upward, 15 g, 15 1 plus g, F applied. 36. I guess it's 11 into 15 is approximately 165 Newton. It should apply a force of a 165 Newton. Okay? I mean, I'm not solving here because I'm solving. Okay, I'll just draw the diagram. This is the monkey. Okay, consider this to be monkey. Rope. Monkey needs to move with an acceleration 1 meter per second square. Then F applied minus mg is equal to mass into acceleration and m g plus a, and g 1 plus 10. Mass is 15 kg. F applied. Force applied is equal to 165 Newton. Now 37 Newton. 37. A monkey is climbing over on a rope that goes over a smooth light pulley. Is climbing on a rope. Let's suppose okay, a monkey is climbing on a rope. A monkey is climbing on a rope that goes over a smooth light pulley and supports a block of equal mass. A monkey is climbing on a rope that goes over a smooth pulley and supports a block of equal mass at the other end. Okay, same mass as the monkey. There is another. Okay, so the system is like this in the 37th question. This is the pulley and this is the rope. There is a monkey. Monkey having mass, and this is M, block of a mass M. Whatever force that a monkey exerts on the rope. Yeah, this is the monkey, and this is these both are the same mass. Show that show that whatever force, I mean it's like this. Whatever force exerted by the monkey, by the monkey, the monkey and the block moves in the same direction, in the same direction with equal accelerations, Okay. Uh, so M, F force applied, B, and this monkey moves upward by an acceleration A. Right? Force applied minus mg plus tension is equal to mg is equal to acceleration, and for this block it will be ma dash and mg minus tension. Force applied is equal to mass into acceleration plus A plus A dash force applied. I need to prove that these two are equal. I mean, we need to prove that these two are equal quantities. I need to consider pseudo force. MA. Since the string is also gonna move, it's pushing the string downward. Okay, if it's pushing the string downward, then this should move upward. I need to prove that. That's not it. And here we have a pseudo force MA. Pseudo force plus MA I guess that's it. A monkey is climbing on a rope as shown in the figure. Climbing on a rope that goes over a light pulley. Weird as. Come on. Quick, quick. I did some shit, not when I mean, okay. So, tension minus M1G is equal to M1A, right? And for the block, M2G minus tension is equal to M2A. And M2G minus M1G, since the masses are equal, M2G and M1G gets cancelled. And minus M1A is equal to M2A. So minus A1 is equal to A2. So acceleration are equal and in same direction Okay. So that's what we needed to prove. Now 38. I mean, monkey questions are actually good, but I have a doubt actually. Like in this question, I asked ChatGPT to explain this shit. Classic monkey block system. Sleeping season. Okay, and give the monkey block. Okay, with an acceleration A. Why it is happening? Climbs harder, accelerating, increases the tension. Okay, pulls up. So it's pushing the tension downward, due to which it's gonna move upward. Okay, that's what happening. See, I'm trying to say that. See, this monkey. I mean this monkey. It's gonna push the string downward with an acceleration A. this string is gonna move. This string is gonna move with an acceleration downward, due to which causing this block also to move upward with an acceleration a, since both masses are equal. That's what is happening here. So whenever we have a monkey and the pulley based system, and if they ask like the on the both sides, the both of the acceleration will be in the same direction and will be equal in the magnitude if the masses are equal. So here the monkey mass and as well as the block mass is equal. So if the monkey puts those string with an acceleration a downward, the block as well is going to move upward with an acceleration a. That's what is happening here. I mean, I don't know why did I choose force apply that shit. Here the tension is providing the necessary amount. In that case, in that ropola, in the 36th question, what is happening that it needed to apply a force, external force, in order to attain the acceleration which it was required. Okay, 38. The monkey bee. Okay, there is a this is a monkey A. Connected. This is tail, and another monkey B. Okay, the monkey B shown in the figure is holding on to the tail of the monkey A, which is climbing up a rope. The masses of the monkey A and B are 5 kg and 2 kg respectively. Okay, this is 5 kg. This mass is 5 kg. 5 kg. This mass is 2 kg. And if A can tolerate a tension T in its tail, tension T is equal to 13 Newton max, T max. Okay. In its tail, what force should be applied on the rope in order to carry the monkey B with it? Yes, 80 Newton. Okay, we need to find the range. The max to max, it's gonna apply 20 because this mass is 20 Newton. Yeah, the mass is 20 Newton. So it's gonna be 70 Newton is equal to tension T. This tension on the rope. 20 Newton plus 30 Newton, that is 50 Newton, 50 Newton plus 100 Newton. Or for the tension T for the block, I'm solving in the book by the way. Block B, I mean monkey B, 30 Newton for the maximum scenario. Five Newton. Tension T, 5 meter per second square, and 25 pseudo force on the block A, and force F, so 55 Newton plus mg 15 Newton, so that is 105 Newton. Okay, pseudo force. What I did, I got it. First, okay, for the block, I mean, I'll consider it to be the block, by the way. This is block B. Here 30 Newton, here 20 Newton, 20 Newton, 20 Newton. So it's going to be 10 Newton. The net into mass into acceleration, since it's 2 kg, 5 meter per second square acceleration, and its acceleration is 5 meter per second. That means it's going to move upward. Okay. Now for the block A, due to the pseudo force, it's going to act downward. And you're still 30 Newton, and it's going to act 5 into 5, that is 25 Newton. Its total is 55 Newton plus the mg, that is 50 Newton, and it's 105 Newton. This is tension T dash, is equal to T dash. So that is the maximum it can have. Yeah. 39th question. Alright, to continue with 39, then complete this NLM. Then we'll move to the friction, and the friction I think you can complete in 1 hour. Let's try to speed run. We need to do theory part, so let's take 2 hours for friction part and circular motion, and all we complete. So yeah, next question will be supposed to solve 39. Alright, 39. Figure shows a man. Figure shows a man. Shows a man of a mass 60 kg. Shows a man of a mass 60 kg. Mass 60 kg. This man mass is 60 kg. Standing on a light weighing machine kept in a block of a mass. So alright. So this is the system which is happening, and the man, I guess the man is gonna pull it. Yeah, he's gonna pull it downward. A man of 60 kg. This mass is 30 kg. This man mass is 60 kg. Supreme Majesty, Supreme. 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 Inferno Majesty. Inferno. Hanging from a pulley fixed to the ceiling through a light rope. If the man manages to keep the box at a rest, what is the weight shown by the machine? Alright, so if this is the man, your attention T, and 60 kg. I'll try to do that.